Welcome to the HardCIDR Networking Academy. My name is LePrevost, and today we will be talking about the VLAN trunking protocol, also known as VTP. This video will only cover VTP versions 1 and 2, since VTP version 3 is very different from the previous two versions. So, with that in mind, let us begin. Before we begin, let me say that Cisco did a terrible job naming this protocol. It's called the VLAN trunking protocol when it really should be called the VLAN management protocol or something similar to that. It does relate to trunking in some way through VTP pruning, which we will cover later, but I think the name can be a little confusing to somebody who is learning Cisco switching for the first time. Add in that Cisco already has a dynamic trunking protocol, which we covered in the last video, and really it's just the name itself is very confusing to beginners in Cisco. Anyway, so what does VTP do then? It is a protocol for syncing and managing VLANs between switches in a network. It does this through VTP advertisements, which we will get into later. VTP also has a very cool feature called VTP Pruning, which can help reduce broadcast traffic across trunk links in your network. So, there are 3 VTP modes in VTP version 2: server mode, client mode, and transparent mode. We will discuss each of these modes in detail in a minute. It is important to note that VTP is completely optional. You don't need VTP in your network for your network to work. Many network admins even elect to turn VTP completely off for several reasons that we'll discuss later, mostly that it's a security vulnerability and it can completely hose your network if you're not careful. The first VTP mode that we will discuss is VTP Server mode. It is the default VTP mode on all Cisco switches. I like to think of VTP servers as the bosses of the VTP domain, as anything they say goes. If you want a VLAN added, it will be added to every switch in the VTP domain. If they want one deleted, you guessed it, it will be deleted. Any change you make to their VLAN database will increment what's called a revision number by 1, which will force a VTP advertisement to be sent out, and subsequently all switches in the VTP domain will make the same change. The syntax is very easy to remember here, just VTP server mode under the global config console. Let me show you the syntax on a live switch and explain some of the output of the show VTP status command as well. So let's go ahead and hop over to switch 1, go into global config mode, and all we have to do here is enter VTP mode server, and it'll tell us devices already in the VTP server mode, and that's because by default every switch is in the VTP server mode. From here we can go ahead and create VLANs. So let's go ahead and create VLAN 100, create VLAN 200, and if we run the output of do show VLAN, you can see that the VLANs are added to the local VLAN database. So let's run a do show VTP status to see what the VTP setup on this switch actually is. Okay, we can see that we're running VTP version 2. Our configuration version is actually 8, so the VLAN database has been modified 8 times, and this is the latest revision. That was actually just me messing around with the VLAN database. I haven't reset it. The number of existing VLANs is 10, so there are currently 10 VLANs on the switch, as you can see up here. It is in the VTP operating mode of server, as we set earlier, and I've already put it into its own VTP domain called HCNA, HardCIDR Networking Academy. So, with that, let's go on to the next VTP mode, which is VTP mode Client, and see what changes between the two modes. The second VTP mode that we will discuss is the VTP Client mode. No changes can be made to the VLAN database from the local switch in this mode. Let me repeat that. No changes can be made to the VLAN database locally. All changes to the VLAN database are processed from VTP servers, which can be both a convenience and a nuisance for network administrators. Let me show you what I mean. Let's hop over to switch 1 again. Oh, here we go. And let's actually change this to VTP mode client. So it's setting device to VTP client mode. And now let's try adding a new VLAN. So let's create VLAN 500. Now look at this. VTP VLAN configuration not allowed when device is in client mode. So what that means is we're not allowed to add, delete, or change anything in the VLAN database while the switch is in client mode. We can only do it if we jump over to another switch that is connected to switch 1 that is in server mode. So if we do a show VTP status over here on switch 2, we can see this is in, this is also in client mode. So let's go ahead and change this one to VTP server mode. And then let's go ahead and create VLAN 500. So let's hop back over there and do show VLAN. There we go. VLAN 500 has been created. But the only reason that VLAN was created on switch 1 is because we had to create it on a server switch on switch 2. So, like I said before, this is the main takeaway about VTP client mode, is that you cannot add or remove VLANs or change the VLAN database in any way in client mode. It's also important to note that any switch in VTP client mode will still forward VTP packets to other switches in the domain. So what does this mean exactly? It means when you bring up a topology like the one we have here, if switch 2 is in VTP client mode, as we can see here, it will still, and switch 1 is in server mode, any change made on switch 1 will be propagated to switch 2 and then across switch 2's trunk link to switch 3, which can either be a server, client, or even a transparent mode switch. It really doesn't matter. But it is important to note that switch 2 will forward packets, VTP packets, even though it can't modify it in any way. Alright, let's take a look at our third and final VTP mode, which is VTP transparent mode. It is essentially a VTP off switch. The switch itself will just ignore any VTP packets that comes its way. It will still forward any VTP frames to other switches in your network, but will not acknowledge anything in those packets. Setting all switches in your network to transparent mode eliminates VTP from your switch network completely. So it's kind of like just having a mail carrier pretty much in your network. So let's go back to our topology here. Let's say switch 1 is a server mode VTP switch, and he sends VTP frames this way down his trunk link to a transparent mode switch 2. When switch 2 receives this VTP frame inbound, it'll take the frame, won't even look at it, but it'll continue forwarding it down to switch 3, which just happens to be, I don't know, another server mode switch. So switch 2 itself won't look at the packet, it won't look at this packet, but it'll forward it on to switch 3, who will do whatever he wants with it. So design-wise, transparent mode switches don't completely mess up your beautiful VTP topology, but at the same time, they can be a nuisance when it comes to things like VTP pruning, which we'll discuss in later slides. VTP is relatively easy to set up and configure. It has a lot of Cisco automatic magic worked in, which can lead to some pitfalls that we will discuss in the next slide. There are only 3 options that you can configure in regards to VTP, and they are the domain name, the password, and the VTP version. The domain name must match between switches if they are to exchange VTP information, but if the domain name is null, it will learn the domain name from its neighbor. We'll take a look at that in a second. The domain name is very easy to configure. Simply type VTP domain and then whatever the name is in global configuration mode. Likewise, the password, which is stored in an MD5, must match between switches in the same VTP domain. It is null by default. The version number is simply the version of VTP you want to use, which I will explain next. So let's take a look at some of this VTP configuration on a live switch. So let's hop over here to switch 1. Here's switch 1. Now let's take a look at some VTP configuration. And then we'll also verify all this with the show VTP status command. So let's configure a VTP domain. We already have one configured, so I'll reconfigure it. So all you have to do is type in at global config mode VTP domain, and then our domain is HCNA. It'll throw up domain name is already set to HCNA, but if switch 2 was set to the null domain, it had no domain set, it would also take on the domain name HCNA, and it would join the VTP domain network. Alright, now let's take a look at the VTP password configuration. Now if we do VTP password Cisco, we'll see that the password has already been set to Cisco, and then we can verify this by doing the do show VTP pass, and we can see the VTP password right there in plain text. So very easy to do, very easy to configure. The password by default is null, and if we hop over to switch 2, we can actually see this. The VTP password is not configured, which in the switch's mind is just telling you that it is a null password. So it does have a password, it's just set to null. So let's go back to our slides here. Let's take a look at the differences between VTP versions 1 and VTP versions 2. You know, I feel bad for the Cisco developer who had to write the code for VTP version 2. The only major change between VTP version 1 and VTP version 2 is support for token ring networks, which don't concern many people these days. VTP version 3, however, is a huge step forward, but that will be a topic of another video. VTP v2 is backwards compatible with VTP v1, so don't worry if you're running versions 1 and 2 in the same domain, because it really doesn't matter. They'll work together, and they work together just fine. You know, it's kind of funny, as I'm editing this video, I'm realizing how many times I'm saying the word VTP, even in just the course of a minute. So if you want to go back and make a drinking game out of these videos, just count how many times I say VTP and take a shot for every time I do it. Yeah, I think you would be dead by the end of this series. Anyway, back to the technology here. Let's look at some pitfalls of VTP v2. You know, there's a reason why VTP is not used in many production networks. It has the potential for melting down your entire network pretty quick. Why is that? Any switch, regardless if it's in client or server mode, with a higher VTP revision number will overwrite the VLAN databases of all the switches in the VTP domain. Let's take a quick look at how that can happen. Alright, now let's take a look at how VTP could possibly destroy our entire switch network. Alright, let's say you know, this is our actual topology here that we'll be working with in our lab. But let's say that you know, we take switch 4 offline for some maintenance. In the meantime, we add some VLANs, we delete some VLANs, which will in turn cause switch 4's revision number, VTP revision number, to increment by a couple. Let's say it increments by 3 compared to the rest of the network. Now when we put these links back, when we reintroduce switch 4 to the network, it will completely override what's in the rest of the network, which could be catastrophic if we just decide to delete delete a couple of VLANs, VLAN 10, which is being used by client 1 over here, or VLAN 20, which is being used by switch 2 for client 2. So let's take a look at that in the actual lab setup I have. Okay, what we'll do here is simulate the scenario that I just diagrammed out a couple seconds ago. And we'll do that by starting on switch 4, and we're going to kill those 2 links to switch 3 to simulate switch 4 being taken off the network entirely. So if we go to enable mode, and then let's just make sure we know which links to take down before. Okay, so it's fast Ethernet 19 and 20. Go into global config, interface range 19-20, and we'll go ahead and shut those ports down and do some maintenance on this switch. Alright, as you can see, those interfaces just went down, and let's go ahead and do a do show VLAN. would help if I could spell do. Okay. See what VLANs we currently have available. Let's just decide to delete VLAN 500. Actually, let's just delete all the VLANs and call it that. So we'll do no VLAN 2 through 1001. That'll delete every VLAN we have. We can verify that by doing a do show VLAN. And as you can see, we only have the default VLANs enabled. And now let's verify our VTP configuration by doing a do show VTP status. And as you can see, our configuration revision number is 10. Currently for our network, the revision number is 9. So while we're at it, just to show how dangerous VTP can be, we're actually going to put this in VTP Client mode, which, as you know, cannot update the VTP or the VLAN databases of other switches under normal conditions. So it is currently in client mode with a higher revision number. Let's go ahead and go back under those interfaces. And perform a no shut and see what happens to our network. Okay, both the links just came up. There's the link status. Let's do it on switch 4 first. Yep, we kept our revision number. Let's jump over to switch 1 and do a show VTP status. As you can see, our configuration revision number has been bumped up to 10. And then let's do a show VLAN to confirm that all of our VLANs are gone. Yep. As you can see, we just completely destroyed our network. Right now, the phones would be off the hook. Fires would be in the server room. Nobody would have their VLAN assignments, and the whole network would be in chaos. So that's how VTP can destroy your entire network with, just by taking a switch offline for a little bit and bringing it back on. So now that I've scared you away from adopting VTP, let's take a look at another feature that it supports. I like to end on a high note, and honestly, VTP pruning is kind of cool. VTP pruning solves a major problem with VTP. The fact that every switch in your VTP domain will know about every single VLAN in that domain. This can create a whole bunch of unnecessary traffic across trunk ports, which is shown by the diagram we have had up before. Pruning will make sure that broadcast traffic for VLAN 10, which is right over here, will not cross the trunk link between switch 2 and switch 3, since neither switch 3 nor switch 4 have clients in VLAN 10. However, will broadcast traffic from VLAN 20 cross that link? Yes, because switch 2 has a client in that VLAN, so it will request that broadcast for VLAN 20 be sent to it. Pretty cool, huh? So pretty much, VLAN broadcast traffic, or broadcast traffic for that VLAN, will only cross trunk links that it actually needs to cross. So, for example, let's take VLAN 20 here. VLAN 20 will broadcast out switch 4's port, out switch 3's port, but it will not broadcast out from switch 2 to switch 1. It will broadcast traffic for switch 2, or for VLAN 20, will stop at switch 2. Likewise, for VLAN 10, broadcast traffic for VLAN 10 will stop at switch 2, just because switch 3 and switch 4 haven't requested that they need broadcast for VLAN 10. And likewise, for switch 1 down here, switch 2 will not broadcast VLAN 20 information about VLAN 20 out, because switch 1 says that it really doesn't need broadcast for VLAN 20, since it doesn't have a client in there. So what does it take to configure VTP pruning? I mean, it seems like a pretty complicated thing to set up, but really it's not. It's one command across the entire VTP domain and you're done. In global configuration mode, you just type in VTP pruning and it will run the feature in the entire VTP domain. That's it. It's pretty much Cisco magic at its best. Okay, let's go ahead and see this in action. We'll hop on over to our lab setup here. onto switch 1, and let's enable VTP pruning. So we'll go to global configuration mode and just go ahead and enable VTP pruning. Oh, that's right, we have this still in client mode, and in client mode you can't modify pruning settings unless you are in server mode. So let's go ahead and change our VTP mode to server. And then we'll go ahead and turn on VTP pruning. Pruning is switched on. So what does that do? Well, you'll be able to see right here under our do show VTP status that pruning is enabled. And you should be able to see this change on switch 3. Or switch 2, I mean. If you do a show VTP status, you'll see that pruning has been enabled for not just switch 1, but for the entire VTP domain. Now let's head back over to our PowerPoint here and talk about the prune eligible list. The prune eligible list is a list of VLANs that are allowed to be pruned by VTP pruning in the network. By default, VLANs 2 to 1001 are prune eligible, which means any VLAN that is created is fair game, pretty much. If you don't want a particular VLAN to be pruned, simply type the command switchport trunk pruning VLAN, remove whatever VLAN, and it will ensure that VLAN will not be pruned. So what does this do? Pretty much the prune eligible list is a list of all the VLANs in the network, and if you don't want that VLAN to be pruned, you can remove it from that list. It's a double negative, and it can be a little confusing. But let's go back to our diagram and I'll kind of clarify this for you. So let's say that, let's get rid of our scribbles again. Okay, let's say that we want VLAN broadcast traffic from VLAN 20 or for VLAN 20 to go throughout the network. We don't want it to stop here at switch 2. We want it to cross all trunk ports regardless if they have clients in that switch or not. Then all we have to do is type in the command switchport trunk pruning VLAN remove 20 from switch 4, or actually any switch in the network. And what that will do is it'll allow broadcast traffic from VLAN 20 to hit switch 3, bounce over to switch 2, and cross the trunk link to switch 1, even though switch 1 doesn't have any clients in that VLAN. So it can be useful for troubleshooting scenarios or maybe some special case production environments. But honestly, you can let VTP pruning do its work and it'll be just fine in most cases. Okay, let's go ahead and wrap things up. Here are a list of 3 essential show commands for VTP. First one is show VTP status, then we have show VTP password, and then we have show interface trunk. Now, the first 2 are pretty self-explanatory. I've showed them to you before. But the show interface trunk command will actually show which VLANs are being pruned on a particular switch port. It'll also show you what's not on the prune eligible list, stuff like that. Well, that pretty much wraps up the VLAN trunking protocol. Tune in next time to learn about VTP version 3 and the exciting new changes that have been implemented. Once again, on behalf of the HardCIDR Networking Academy, I would like to thank you for viewing.